All right, guys. So any questions from homework? If you notice, I've changed some of the due dates, just so you don't freak out too much. I will tell you this. Here's what I want to have happen. I haven't officially rewrote the homework timeline sheet, but we're going to have a quiz this Thursday on 3-1 through 3-3. I'll say that again. We're going to have a quiz this Thursday, 3-1, 3-2, 3-3. So we're going to focus probably today and tomorrow on 3-3. All right, so everybody with me. So I think when I made the homework timeline sheet, I was a little insane about where I put that quiz. It was supposed to happen last Thursday. That was kind of insane. So it's all right. Past Jeff, he was a little crazy. Let me see, where am I at? Okay, not too bad. All right, so no questions from anything. You guys are doing fantastic with homework, chapter 3 homework especially, right? I mean, yeah, maybe. I've graded a few of them. So if there are no questions, we're going to jump right back in to where we left off. I have put a couple of handouts up on Canvas. So if you go there now, let me show you where they are. Let me get this over there. Bam, bam, bam. All right, you guys can see my canvas. You can see my canvas. If you go to modules and you go down to unit 3, which is crazy because that's where we are, I've put a couple of handouts. Good old solving basic equations. So I wanted to augment the books stuff. So there's a lot of examples to go through here. So we're going to look at this in a bit. Right, so that's up there. And then there's I call it solving general equations, but it's really just solving a little more complicated equations, right? So this is the bread and butter of algebra, right? Solving equations is the bread and butter of algebra. If you can't solve equations, you can't do algebra, period. So obviously we're going to focus some time on that. And that's really what 3-1 and 3-2 has been getting us ready for, is realizing where some equations come from. And then we can open up the door to all these different equations. So 3-1 and 3-2, you were creating your own equations based on some situation. A lot of them dealt with snow cones. So, you know, it's just the way it was. Somebody pointed out an author was a snow cone owner. I can't remember now. That's fantastic. I'm not that observant, so I'm happy somebody pointed that out for me. So let's do this. Let me stop sharing that. Let me highlight myself. And let's go back in the book for just a little bit, and then we'll go to my little handouts. Where are you, book? There you are. Let me put you guys over there. Bam. Put you up there. Bam. All right, where am I? Oh, okay. So we finished section 3.2. One thing, all right, a very important thing about this. Let me see. Let me do this. Yeah, I'm going to stop sharing. I'm going to go work on my board here a little bit. Something that's really disturbing, and I want to make a real big point of it right now. All right, so this is just some line, right? Let me see if you guys can't even see that. Hold on. All right, so there's a line. Can somebody describe to me where the x-intercept is of that line?
Not very accurately.
Well,
about.
I don't mean, don't tell me what the answer, what the actual intercept is. Tell me where it is. How would you find it?
Um,
On the x-axis?
Yeah, it's where the what hits the x-axis. It's where the line hits the x-axis. So it's whatever point that is would be the x-intercept. So if I have a different line, my line now goes like that. Wow, the x-intercept would be that point right there. Is that everybody with me so far? And now really, really stay with me. Ian has a really good point. I have not given you any scale at all. You can't tell me what the intercepts are, but you can tell me one thing about them. You can't tell me one thing for sure. Do you know what X value that is? No idea. I didn't give you scale at all, did I? Because I'm an asshole. But what's the Y piece of that point? You know that for damn sure. I don't care what the scale is. What's the Y piece of that point? So I don't care. I don't know what the X is. No idea. But what's the Y piece? Is it 1? Is it -1?
0.
It's 0. Yes. What about that dude? Totally different point. But, so I don't know what the hell the X is. Again, I don't know what the scale is here. It could be crazy. So I have no idea what that is, but I know what that is. I know what the Y piece is. Is it 1? Is it -1? Again, it's. You guys can
0.
0. You guys. All right. So what can I say about all x-intercepts? If I say I have an x-intercept, you don't, here I have a line, it's got an x-intercept. That's all I say. What do you know? You know this is 0. Has to be, because otherwise it wouldn't be on the x-axis. If that is something other than 0, didn't it go up or down away from the x-axis? Isn't that what the second dude means? Up and down? Every x-intercept must have a 0 there. So that's why it's concerning to me in the book when they said, find the x-intercept. People are giving me 413. What? No. That is not an x-intercept. So again, on that one, your scale isn't specific. That's why they say estimate. Estimate what it is. Right? So if my scale was here, let's see if I can do something. 1, 2, 3, 4. And I said, estimate this x-intercept. What would your estimate be?
Like
Say again, sir?
3.5.
Like 3.5. That's the best I can do. Maybe it's really 3.4785. I don't know. From what I've given you, the best I can do is estimate it to be 3.5. That's what an estimate is. So your answers to that one question where it's asking you to estimate the x-intercept, you'll have different numbers here, but everybody better have a 0 there. Because that's the only way it can be an x-intercept. In fact, let me see if I can push this a little bit. Yeah, sure, why not? I'm going to erase all this. If I have an equation, and this should look a little more familiar to us, this kind of thing here. All right, can somebody tell me what the slope of this is? Anybody tell me what the slope of that is? Say again, sir. I couldn't tell what you said. 1.2. That's the slope, right? Because again, we've seen this a few times now. The equation of a line, slope times x plus this. All right, now go with me, What did we say a minute ago is always true about the x-intercept? What's always true about the x-intercept?
Y is 0.
Yes. Good Lord, Jeff. I have no idea. I don't know what language that is. What is always true? Question mark. y is 0, right? That's what we were saying earlier. This piece will be 0. So how could I find the x-intercept of this equation?
+5.
No. What's my very first step?
Right.
No, stop. What's always true for the x-intercept? Y is 0. So how can I rewrite this so I can figure out what the x-intercept is? Y is 0, so what would I put here?
0.
0, okay. And then I have to solve this, right? So that's what we're gonna focus on today. And you can see how this is not a bad way to do this. Lines, we can see how they represent real life situations. You guys with me? Unfortunately, we're really experts on how lines deal with snow cones, but they deal with more than just snow cones. So we can see how to construct the equation of a line from some given situation. We've done that a few times. Now that we have an equation, I can use it to figure out certain situations, like what's the x-intercept, which if it's a profit function, that would mean my break-even point, right? Doesn't have to be that. It could be any function, but that would be for a profit function, that would be my break-even point. We very often want to know what the x-intercept and the y-intercept are because they have special meanings. Okay, maybe. So I'm not going to solve this yet. Some of you guys might know how to solve this, but I want to focus today on how to solve equations. And you can see where the idea of needing to be able to solve an equation comes from. I like it. All right, so I'm going to put that up in the corner. We'll figure that out here in a bit. I'm going to erase all this. So we talked a little bit about the idea of solving equations. And the idea really is somebody took, so this isn't, let me see. All right, this is very interesting. There's a way to teach this so you can see the mechanics. I really want you guys with me. Stay with me. So you can see the mechanics of solving equations. But if you focus just on the mechanics, you don't understand where equations come from in real life. So in real life, you've seen a couple situations when I create a line based on snow cone business, right? But most equations that govern real life are not simple linear equations. You probably know that. They're going to be with some squares in there and some cubes and some square roots and some weird shit. The equations that talk about where a hurricane is going to go are not linear equations. You can tell that, Florida gets beat up all the time. You can tell that when you have this hurricane coming, and it's curving all over the place, and it has the cone of uncertainty, right? So this thing is not a straight line; it's curvy. The equations that govern that.
I've seen that drawing.
What's that? My drawing is disgusting.
I've seen that drawing on TV.
Huh?
I've seen that drawing on TV.
Oh, good. All right. Of course, some officials like to Sharpie in their own interpretation of things, but we won't talk about that.
That's where I saw it.
Yeah. Yeah. Or anyway, I'm not gonna. So to learn how to solve equations, and equations come from observations we make, and they will sometimes be a lot grosser than the ones we've worked with, but the ones we work with are still valid. They still work in very simple situations. So we have equations that can be created based on observations. Now I want to talk about just the mechanics. So this has got nothing to do with real life. This is not the way an equation would come about in real life, but I've done this with you guys once already. So we have a value of X. And then somebody did something to it so that they could do 7 times X. So if X is 2, what's 7 times X? If X is 2, yeah, 14, right? Is that cool? Right? So the point of an equation, so this is kind of like the idea behind what I do. If somebody gives me an equation and it says 5x equals 30, that if somebody started at x equals a number, did some shit to both sides and got this equation. So I'm trying to undo what somebody did. So obviously, they start with a number, and what did they do? They start x equals some number. I don't know what the number was, but they did what to both sides? Like we multiplied by 7. Yeah, they multiplied by. What? I don't know what that was. All right. They multiplied by 5. I believe I heard somebody say that. So how would I'm trying to get rid of this number then. That's what I'm trying to do. I'm trying to get rid of all the shit that happened to my poor little x so I can figure out what that number was that is equal to what x is. So I know what x is then. So how do I get rid of that 5? Well, the operation is multiplication. So I have to do the opposite. Solving equations is all about doing the opposite of what was done, which makes sense. I'm trying to undo the shit that was done to my x. So how do I kill multiplication by 5? What's the opposite?
Divide.
Divide.
Divide by 5. I like it. And you got to do it to both sides. Otherwise, the equality wouldn't be true anymore. So you get x equals
6.
6. Thank you. Okay. Now that's a very simple equation, right? So another quick example, and then we'll kind of ramp it up a little bit. So what if I had this guy? What do you got, Jeff? Nothing major. Let's do. Yeah, I like it. So you say to yourself, you find your x, there's my x. What's being done to the poor x piece? Somebody's adding 4 to it. Get that out of here. How do I get that out of here? How do I cancel that? Adding 4. What would I do? What's the opposite of that?
You minus 4.
Yeah, subtract 4. I love it. So these actually cancel. So I get x equals.
-6.
Good. -6. Kick ass. All right. I like it. And again, I know that some of you guys are like, oh my God, dude. I know all this shit. That's great. Enjoy it. I'm talking to people that don't, or it's been a while. So just, hang out. All right. So let's add. So watch this. I want you to realize, all right, I'm going to build another problem kind of off of this one. What if instead of x plus 4 equals -2, what if it was, let's see if you work. You're nifty. I can't get high off of that. What if it was 2x plus 4 equals -2? So my first step wouldn't change. I still want to get my x piece by itself. So I would still subtract 4 first. All right, so the same exact first step. But am I done when I do that? No, what do I have to do now to get my x by itself?
Divide.
Divide by 2, I like it. Now I know x was -3. And real quick, I haven't done this yet. We did this before together, but if I go to check this, how would I check this to make sure it's right? Let me make that look more like a 3. How do I check this to make sure it's right?
Where
What do I do?
it is.
Plug it into the original equation.
Yeah. So if I take -3, because the idea behind this is if this is true, then this is true. So how do I check it? I take that and I plug it in. I make x -3. And is that true? What's twice -3? Twice -3 is?
-6.
-6 plus 4 is -2. It works. It makes it true. I like it. So let's do this. Let's transition to my little handout. See if I can put myself out of the way. Let me bring this bad boy up. There you are. Come here. All right, let me bring you guys over here. Where are you? There you are. All right, so if you go to Canvas, actually, let me show you this real quick. If you go to Canvas, where's Canvas, Jeff? I don't know. There you are. There you are. Okay. Bam. So again, if you weren't here a minute ago, if you go to Canvas, if you're able to right now, go to Modules, go down to Unit 3, and this first one, Solving Basic Equations. And then you can download it. You can just look at it, whatever you want to do. All right. So I'm going to bring it up on my computer so it's just easier to work with. Where'd you go? There you are. All right. Now I should see the solving basic equations, right? So I give you a couple of things. So one thing I want you to realize is this is a very early fundamental algebra problem where they just give you an expression and they tell you what the variables are and you plug them in. So obviously that ability is important if you want to check your equations. Then I give you some examples of starting with an answer and doing shit to it, starting with an answer and doing shit to it, right? And then so that sets up the idea of the mechanics of how to solve an equation. You're trying to undo all the shit that somebody did to my poor little variable, right? Just trying to get my poor little variable by himself. So here's an example, x minus 5. So of course I add 5 to undo that. Another example, 2x equals 6. So I divide by 2 to undo that. And then I know what the value is. And then I can check it by plugging it back in. How's everybody doing out there? All right. So again, this could be very basic for some of you guys. Fantastic. Love the shit out of that. Just appreciate it. For those of you that haven't done this in a while and you forgot how to do this, I'm talking to you. Let me know. So let's do some of these things together. And then I'll you guys on the other side.
Bluetooth connected.
Oh my goodness. All right. I always forget to set this thing up. Oh shit. Oh, there you go. So on this first one, all right, so these are going to be still very basic. You can find your variable. There's my variable. How do I get that poor little dude by himself? Well, you look at what's being done to him. Why is he not by himself? Because that's stupid 11, right? I don't want that 11 there. I want my variable all by himself, right? Poor little dude. So how do I kill that 11? What's the operation?
Add 11.
Yes. So right now it's subtracting. So I'm going to add 11. And whatever I do to one side, I've got to do to the other side. And I think I told you last time about Indiana Jones and the golden statue, and he didn't balance his equation. So if you don't do this correctly, big boulders might come at you. That's all I'm saying. Right? Make sure you grab your hat. Always got to have your hat. So now if I do this, these do cancel. So I am left with just an x. And now I know x is 20. Now, to be very honest, Let me rewrite what that equation said. When the equation is really, really basic, there's barely anything going on, you don't need algebra. If I just said to you, I have a number and I take 11 away from it and I get 9, you could just go, oh, that's 20, right? You don't have to write down the equation, because we know if I said I have a number and I took 11 from it, or I have some money and I gave that guy $11 and I have $9 left, how much money did I have to begin with? You're not even going to consider that as an algebraic problem, are you? You're just going to know to add the 11 back on to see what you used to have. But that's what algebra does. It shows us what we're doing mentally, so that when the problems become more disgusting, I don't have to do them mentally. There's going to be too much shit going on. All right, maybe you guys are with me. So to check this, right, I want to check this. We do that in a different color. Why would you do that, Jeff? I don't know. Just go with it. To check it, I just put the 20 in. 20 minus 11. Holy crap. Is that a 20? Minus 11 equals 9. Check. That's true. So that must mean it's the right solution. No other number could possibly work, which only makes sense. What do you take 11 from to make 9? There's only one number that works for that. All right. Keep going with me. You got to let me know if this is freaking you out. Do not be concerned if you think, well, I don't know what's going on, but everybody else does. That's bullshit. All right, so you must let me, this is huge. This is really crazy important. If you cannot do this, you cannot do most of math. So this is a little important. So what's going on here? Why is my poor little X dude not by himself? I know this is basic. Just go with me.
Divide.
Well, it's not by himself because that dumb 3. That dumb 3 is multiplying my poor little X dude. So I'm going to do the opposite. It's always about doing the opposite of what's happening. So I'm going to divide both sides by 3. Immediately do it to both sides so you don't forget. Now watch real quick. Well, let's finish this out, and then I want to show you a really common mistake people make. So those 3's cancel. I can see them canceling. So I get X equals, and of course, negative 12 divided by 3 is negative 4. Bam. Right? Why did I? Oh, I should have changed my colors back, but too bad. Oh, crappity doo-dah. Rah. And then if I want to check it, all right, 3 times, and I put negative 4 in place of X, and that is true. Check. A very common mistake that I see on this problem. Get in there. Very common mistake I see on this problem is somebody will say, okay, 3x equals negative 12. Subtract 3, so x is negative 15. Yeah, I'm done, Jeff. What would you tell this person to let them know they did not do this correctly?
You can't undo multiplication by subtracting.
And I'll say exactly that. I'll say subtraction is not the opposite of multiplication. How the hell? What can you put 3x and negative 3 together? Are those like terms? No. So that doesn't make any sense. That doesn't do what I want it to do. The operations have to be opposite. I've said that a few times before. In order for things to cancel, the operations have to be opposite. That actually just makes sense. If the operations are opposite, they will undo each other. But you would be amazed at how often that mistake is made. Or maybe not. Maybe some of you guys are like, I don't see any problem with that, but hopefully you see a problem with it now. So look at number 3. Number 3 is a little bit freakadelic. Why is my X not by itself? Oop, let me just make this. Why is the X not by itself? It's got the crazy what? It's
8.
negative 8, right? So how would I kill -8? How would I cancel -8?
Add 8.
Yeah, beautiful. I love it. So I know this is addition. It would be really gross. Well, I'm not even gonna say that. Hopefully you guys see that if I add 8, that cancels this part out. And I must do it to both sides. So now I'll have x equals, and what's -11 plus 8?
-3.
All right, I like it. Is -3 the funniest number? I don't know. Or something else has happened in your place. And then if I go to check this, -8 plus, put a -3 in there in place of x equals -11. That works. Check. I like it. So there's another, so just to kind of look at this one again, another mistake. It's the same mistake I said earlier, but this time it's easier to make this mistake. -8x equals -11, and somebody adds 8 to both sides. Why is that wrong? That is a mistake. Why? It's the same reason, but it's kind of harder to see it. What's the operation here?
Multiplication.
Multiplication. So addition cannot cancel multiplication. That's why. But people focus in on that's a time symbol there, right? Let me get rid of that stupid thing. Get out. Stop bothering me. Go away. All right. People focus in on that. It's a -8, so they think +8, but the operation is what's important. It's multiplication. So you would actually have to divide both sides to do it. Okay, what about number 4 here? What's happening to my x?
It's being divided by 6.
Being divided by 6. So I have to undo that division. So I'm going to do what to both sides?
Multiply 6.
Yeah, so if I multiply both sides by 6, these cancel. So I get x by itself, and 3 times 6 is 18. Done. So if I check it, Jeff, x over 6, so I'll put 18 in place of x, and sure enough, 18 divided by 6 is 3, check. So I know that's right. All right. So the equations are going to start to get more complicated, but the idea doesn't change. I'm trying to undo all the stuff that happened to my variable so I can get it by itself, and I'll know what the hell it is then. If I can get the variable by itself, it'll be equal to a number. Bam. That's what x is. Or whatever the variable is. It doesn't have to be x, to be honest. All right, so you guys, anybody still need this? I'm sorry. Anybody still copying? No? All right, so I want you guys to work on, let's just do these 4 for right now. Right there. And of course, if you've got the paper up and you get done with these quick, just keep going. But just do these 4 for right now. Check my mail. Let's see if I do that. Oh shit. Can you guys still see the equation stuff? Yes? Okay. What? Don't forget to check it. It should be pretty quick. So I'm going to start looking at these. I'm going to start catching up to you guys. On part A, it's x plus 7, so I'm adding 7. I don't want to do that. I want to get that by himself, so I'm going to subtract 7 from both sides. I get negative 10. Cool. And then to check it, I'm just going to take this statement and I'm going to make x negative 10 to see if it's a true statement. And that is a true statement. I like it. You guys are working so hard. I love it. So now, part B, to kill that negative 5, I have to add 5 to both sides. That's the only way to make that go to 0, so there's no numbers left. There's only that x left. So the x is 12, and if I check it, negative 5 plus put a 12 in is 7. Check, that's true. What really sucks is when you go to check it and you don't check it correctly. You do this work wrong and you think you're wrong. That sucks. So here, this is negative 12 times x. So I have to divide to kill that multiplication. I can't just look at the negative and think I'm going to add, because addition will not kill the operation. You're trying to kill the operation. So it's times. So I better divide by negative 12. And 48 divided by negative 12 is negative 4. So if I go to check it, negative 12 times negative 4 is positive 48 because the negatives cancel. That makes sense. Are you guys? I think you guys are just finishing the whole thing. I love it. All right. What about part D? Again, there's my variable. The only thing that's with it is just divided by 7. I don't want that divided by 7. So I'm going to do the opposite operation. I'm going to multiply by 7. 7 divided by 7 cancels. 3 times 7 is 21. And if I go to check this, 21 in place of x over 7 equals 3. Check. That works. All right. Any questions on those first 4? I mean, those are the real basic equations. There's only one thing happening. So, of course, the next level is going to be if there's a couple things happening. So go ahead and do these 3 if you haven't done these yet. Try to. They might get a little bit freaky depending on how much you know equations already. Whoa. Oh, okay. All right. Freaky. All right, guys, let me look at this part E problem. And I want you to realize, so guys, if I ask you, real quick, if I ask you, what number do you take 1 away from to make 11? What number do you take 1 away from to make 11?
12.
12. It's crazy. So that's pretty much exactly what the first step of this is going to be. I find where my x is, and I get rid of anything else. So there's my term that has the x in it. Don't divide by 4 yet. If you divide by 4, you're going to make all these fractions that you don't need. Do you guys see that? So you almost always, let me write this down, almost always, I got 1 extra hump in my W. That's really weird. Almost always write better than Jeff. Almost always, crappity do that. Divide last. Because if you divide too early, you make a bunch of fractions that you shouldn't have to deal with. So let me see here. Let me erase this piece. Got it. So I want to get 4x by itself. Why is it not by itself? The stupid 1 is subtracting, so I'm going to kill it. Add 1. So the 1s here cancel, right? -1 plus 1 is gone. So the only thing left on that side is 4x. There's my equal sign. 11 plus 1 is 12. So that's exactly what we just said a minute ago. What number do I take 1 away from to make 11? That number would have to be 12. That's exactly what the algebra tells me. And now, of course, what's the last step?
Divide it by 4.
Yeah, because this is 4 times x. So to kill it, I got to divide. So I undo that operation. So I get x is 3. And if I want to check it, Jeff, you don't have to be all color-coded. Yes, I do for some reason. 4 times x, which is 3, minus 1 equals 11. 12 minus 1 equals 11. Check. So I know I'm right. So what about part F? What did anybody do that one yet? What did you do first?
-6 from both sides.
Good, good. So here's where my variable is. So why is that piece not by itself? Because of the dumb 6. So let me subtract it. Die. So now what I have left on this side is negative 5x, and then 11 minus 6 is 5. And then, of course, the last step, what do you do? Do I add 5? Yay. I like the look I just got. Good. No, of course not. I mean, come on. That's why I asked it. I didn't say it.
Divide.
Good. So the operation is multiplication. So you have to focus on the operation. The operation is multiplication. You want to divide by negative 5. Die, die. So x is still here. There's my equal sign. 5 divided by negative 5. Negative 1. So let's check this. So if I check it, I would do 6 minus 5 times x, but I'm going to say x is negative 1. 6 plus 5 equals 11. Check. So I know I'm right. Nah. A decent question right now would be, does every equation have an answer? What do you think?
No.
Good. I mean, it's real life. So mathematics, a huge chunk of it, not all of it, describes parts of real life. So in real life, there are situations that have no solution, right? I don't care how optimistic you want to be. There are situations that have no solution. How do we make it so my lemonade stand makes $18 billion in the next 3 days? That has no solution. Okay, stop. Ain't gonna happen. It ain't gonna happen. That's gonna come up later. We're gonna see what has to be true about an equation. How does it tell me that there's no solution to it? So we're gonna see that later. We're not gonna see that quite yet. Part G is probably the freakiest one on here. Anybody have an idea what to do with part G? What's different about part G?
There's an X on both sides.
Stupid. Yeah. There's an X on both sides. Makes me think about Exxon gas, but no. So it kind of makes sense. This is on the next little handout, but the idea when there are variables and numbers on both sides, I want to get the variables on one side and the numbers on the other. Really, Jeff? Variables on one side, numbers on the other side. So how would I, for example, let me delete all my little underlinings. Gather. How would I get my X's together, which means I want them to disappear from one side? How would I cancel, for example, how would I cancel these 3 X's right there? What would I do to both sides to kill these? Sorry, I always forget. You probably can't see it when I'm just hovering over there. How do I kill these guys? Kill them.
Subtract 3x from both sides.
Yeah, so if I subtract 3x, and let this be cathartic. If you hate math, then get a little bit of glee by killing parts of it, right? Die, math, die. So I don't know. If you're not that violent, if you don't like my Game of Thrones approach to mathematics, just think of it as canceling it or moving it. We're just moving it to the other side, but I much prefer to think of it as killing it. As much as I love math, it's kind of fun. So 3x minus 3x, that's gone. So the only thing left on this side is the 4. And what do I get on the other side? 8x minus 3x.
5x minus 11.
I like it. And the minus 11 is still there. So I'm trying to remember to show you guys, be very organized. You can be your own worst enemy when you're doing these. I see so many people like doing stuff on the side and then you throw it back in the equation and it goes in the wrong place and holy shit. You don't want to do that to yourself. It's already difficult enough. Don't make it more difficult. So be very organized. That's gone. The 4 is there. The 11 is there. 11, Jeff. The equal sign. Did I just look at the equals and say 11? I did. And then 8x minus 3x is 5x is there, and then the minus 11 is there. Bam. Some people don't like that. I don't care, right? There are creative parts of mathematics. This is not quite one of them, right? This is where you want to be nice to yourself. You want to be organized. Now, can I ask you this? Let me see if you guys get this. What is still in the wrong place? What piece of this is still in the wrong place?
Negative 11.
Yeah, that's stupid thing right there. See, all my x's, all my variables are right there. So this is the variable side. It wants to kick those that 11 out of here. So I'm going to add 11. So now on this side, I get 15. There's my equal sign. There's my 5x. And then these 11s kill each other. Dead. And now, of course, the last thing I do is kill this multiplication. Divide by 5. And I get 3 is x. I can also write that as x is 3, however you like. So that's a very fundamental aspect of solving slightly more complicated equations is get all your x's on one side, get all your numbers on the other side, and then your last step is almost always divide. Divide by whatever the coefficient is. So how do I check that? The same way I always do. Try to take over the word. No, stop. So I'll do 3. I'm going to rewrite the equation. 3 times x. X is 3. Right? So I'm going to put a 3 right there. Plus 4 equals 8 times x, but x is 3, minus 11. Let's see. 3 times 3 is 9 plus 4. 8 times 3 is 24 minus 11. 13 equals 13. Check. So I know that x equals 3 works. It's the solution. And again, everybody in this class has such different backgrounds. It's crazy. Some of you guys are bored to tears because this is really easy for you. Some of you guys are still like, I don't even know what to ask right now. And then some of you guys are a combination of those things. Okay, I know. All right, so that's it for that handout. Let me see what time we got. Okay, good. I want to do a little bit on the other handout. So let me stop sharing and pull that bad boy up. Where are you? There you are. All right, so I just want to do a little bit of this bad boy because it's got a lot going on. All right. So this is up on Canvas in that same place. You can reference it as much as you want to. And this is where I've got the whole idea of move your variables to on one side and the numbers on the other side, right? That's what we just discussed. But this is going to have something else going on. This is going to need distributive property because we're going to have stuff like, see this, here's an example equation. So this part right here really sucks because one of the main things I want to do is be able to move shit around. And do you see how the x minus 5 are stuck inside of this dumb parenthesis thing? So the whole idea of distribution is really so I can free things up so then I can move them around. Because I want to move my x's to one side and my numbers to the other side. How can I do that if they're stuck inside of here? So one of the very first things I do is in any equation, if there are parentheses, I go there and I distribute. So then I free those pieces up. So 3 times x is 3x and 3 times negative 5 is negative 15. So the only thing I did there, let me get rid of some of my drawings here so you can see better. The only thing I did there was rewrite this as this. I just distributed the 3. That's the only thing I've done. Everything else is the same. And then you combine like terms, kind of makes sense. I could put the 2 and the 15 together, right? 2 and minus 15, minus 13. And on the other side, I could put the negative 4 and the negative 3 together to make negative 7. And then I've got a problem just like we just did. I've got x's here and here. I've got numbers there and there. Oh, shit, it's crazy. So I want to move these x's over there. So I kill them here. And I want to move those numbers on the other side. So I undo them. I add 13 so that it shows up on the other side. And then I end up with a really beautiful little simple equation down there where all I have to do is divide the 2, which is what I do. And then you can see the check. Just put a 3 in place of wherever the X is, put a 3 there, and then make sure that it actually comes out to be true. All right, let me stop for a minute. Some of you guys are already going. I don't know why I put part A up there. That's a nice one. So do part A, it's a little layup. And then do part B and C. And of course you can do the whole damn thing if you want to get ahead. Actually, this is, we're supposed to, I don't care. You guys can do it. Oh, she make it back? Let's see. Oh, you made it back. Okay, I just got your email. All right. Part A should be, okay, there's no parentheses, right? So there's no distribution part. So there's where my variable is. So I want to get rid of this guy. So I'm going to subtract 3 on both sides. So then I have 2x. There's my equal sign because these guys kill each other. 9 minus 3 is 6. For some reason, I have a fascination with 2x equals 6. That's shown up quite a few times. I didn't really give you enough room to check your work because I'm evil. If I check my work, 2 times 3 plus 3 equals 9. 6 plus 3 equals 9. Check. So that is the correct solution. So in part B is just one step up. Some of you guys might realize there's another way to do this problem, but I'm going to go ahead and distribute the 2. Change back to blue. So I get 4x, bam, minus 10 equals 22. And now this looks like something we've dealt with before. The 10 is in the wrong place, so I'm going to add that over. And then if I divide by 4, I get x is 8. And again, every step I'm just thinking to myself, what's the opposite of subtracting? Add. What's the opposite of multiplying? Divide. So you guys got 8? And then if you check it, again, I didn't really give them enough room for this. Let me see if I can do it up here. So if you check it, twice 2 times 8 minus 5. 2 times 8 is 16 minus 5 is 11. 2 times 11 is 22. Check. That works. Hey, whatever you're doing right now, stop doing it for a second. Look at E, just look at E. Just take a minute and just look at it. Just put your eyeballs on this thing. It's so pretty. Now, people will look at that and they will freeze up because there's so much shit happening. But here's the idea. Here's the point. We're the freaking humans. If I don't want to look at everything, I don't have to, right? I naturally look, and this is what you need to develop. I look for my distribution parts, and then that's all I have to worry about. The rest of it just comes for the ride. I don't have to worry about it. So I always feel like students think you're supposed to worry about all the parts of a problem. That is insane. You're never going to be able to do shit if you think like that. I only focus on what is immediately important. Everything else just kind of comes for the ride. So coming back here to C, there's a lot less stuff happening up here. But the first thing I would do is distribute that 5. So 5 times 2, and then 5 times negative x. And then I put together all the like terms I can on this side, which of course will be 3 and 10 and negative 4. So this will be 13 minus 4 is 9. And then what's in the wrong place on that step? What's in the wrong place? What needs to be escorted away? What piece is in the wrong place? Does that make sense when I ask that question? Where are my x's? They're right there. Where are my numbers? Oh shit, they're scattered. So obviously this guy is in the wrong place. He's supposed to be on the number side. So I'm going to subtract 9. Whoa, what's happening out there? And then the last step is going to be to divide by negative 5. So I get 3. Now, some of you guys, as much as you might kind of dislike this, there's an element of solving a puzzle to this that, especially when you get to an answer and it works, you're like, oh, that's kind of cool. It's the moment your answer doesn't work or you don't know what to do, then you're like, oh, all of this is shit. But it is kind of a puzzle. And if I go to check this, 3 plus 5, 2 minus 3 is negative 1. Just to kind of make this quicker, 3 minus 5 is negative 2, minus 4 is negative 6. Check, it works. It works when I plug it in. All right. I think we're going to stop there. I don't want to do too much of this. I can sense that you guys are getting up to the I've had enough of this for the moment, Jeff, thanks, part. So we're going to go ahead and stop there. We're going to obviously finish this next time, and then we're going to get back in the book and see what the problems look like in the book. Any questions on what we did on there? Anything? And if you want to, you can finish this up on your own time if you want to. We'll take a look at these tomorrow. I'm sorry. I don't know if anybody still needs that. All right. So I'm going to go ahead and say class is over. Let me know if you want to hang out for a bit. Just let me know if you have any questions. Otherwise, you're free to leave. Y'all good? I'm going to head out. Bye, guys.
Bye. Bye.